Hi all, so in this video I'm going to be balancing some redox equations. Now to find the rules in balancing, it's at the top of this worksheet, there's a worked example, but also it's on the PowerPoint chapter 5. Okay, so we're going to just start with a nice and basic equation. So this is one of the ones that I'm going to be going through. So this is a redox equation. Now to prove that it's a redox equation, we're just going to work out the oxidation numbers and we're going to see what the reductant is, what the oxidant is, what's reduced and what's oxidized. Okay, so one thing that we need to keep in mind is that the reductant is itself oxidized. So the reductant is what it's doing and oxidized is what's happening to it. You may also call it the reducer, and you may also say it's undergone oxidation. Now the oxidizer is called the oxidant and it's reduced, or you may say it's undergone reduction. Okay, so because the reducer is oxidized and oil rig, oxidation is loss of electrons, the electrons go this way from reductant to oxidant. And why am I doing that going that way? These gain electrons. Okay, so when you are looking at a redox equation, we've just got to make sure the Mn starts at 2 plus, and then, minus 2 gives us minus 8 as a total, positive at 7. So Mn is oxidized, it is the reductant, losing electrons to, now let's work out, so this is minus 2, minus 1, minus 6, minus 1, so plus 5, so it goes from plus 5 to plus 3, so that's reduced, so losing electrons to bismuth. Alright, so when you're writing the two equations, you've actually got to do them as half equations. Oxidation half equation we will do here, so that's Mn. So Mn 2 plus to MnO4 minus. So first you balance for elements other than H and O, and that's already done. Then you balance for oxygen by adding water, so we're going to have to add 4 waters to balance for those oxygens. Then you have to balance for H plus, by adding H plus, and we're going to have to add 8 H pluses. Then you have to balance for charge, so you have a look overall, this has a plus 2 charge, and on this side it is a plus 7. So we have to add 5 electrons, and it makes sense because it goes from oxidation number plus 2 to plus 7, so it's lost 5 electrons. Then you have a look at your bismuth half equation, and that would be reduction. Oxidation, by the way, electrons on the product side, so on the right. Now, for reduction, this would be aqueous, all ions will be aqueous. Okay, elements other than H and O, done. Oxygen by adding 3 waters. Hydrogen by adding 6 H pluses. Then we count the charge, plus 6 minus 1 is plus 5 on this side and plus 3 on that side, meaning that we have to add 2 electrons to this side. And it makes sense because bismuth has gone from plus 5 to plus 3, meaning it's gained 2 electrons. Then when we provide the overall reaction, we need to make sure that the amount of electrons lost is the same as the amount of electrons gained. So the way we do that is we times them both by a factor so that they equal each other. So 2 does not go into 5, so we're going to have to times this one by 5 and times this one by 2. So we'll write it out again. So Mn2 plus 2 of those plus 8 waters plus 5 BiO3s plus 5 by 6 is 30 H pluses plus 10 electrons produces 2 MnO4s. What the? Where did I get that from? Hang on. What? Oh, 38. Oh, I thought it was 30H pluses. That's weird. Okay, anyway, keep going. Plus 16H plus 10 electrons plus 5 Bi3 plus and plus 15 H2Os. Then we balance, and now we have to cancel out things that appear on both sides because we need to provide the net equation. Now we are crossing out electrons, we are crossing out H pluses, all of these go, and this remains 14. Waters, we need to end up having waters on this side, and we need to have 7. Okay, so we'll rewrite it out nicely. Oops, this one's crossed out. Okay, and that should be it for that one. Let me just get the next equation. So that's, in the end, 14H pluses, 5 BiO3s, 2 MnO4, 2, 8, and 2, 7, and 5. Perfect. Okay, so for the next one, oops. Okay, so for the next one, we are going to actually do one that is close to us, and that is the production of ethanol from the fermentation of glucose under anaerobic respiration. So C6H12O6 produces C2H5OH, 2 of those, and 2 CO2. This is one that you have to know. Now, if we're going to work out which one's oxidized and which is reduced, we just do it like normal. You can work out the average oxidation number, minus 12. So this one has to be 0 on average. Means plus 6 minus 2, equals minus plus 4. That means this is a minus 4. There's 2 of them, so minus 2. And this would be minus 2 plus 4. Okay, so this is oxidation. So carbon in glucose oxidized to carbon in CO2. Okay, so let's write that out. Now we balance for elements other than H and O, so that's the carbons. Then we balance for oxygen by adding water. So we have 12 oxygens on this side, and we only have 6 on this side, so we'll need to add 6 H2O. Then we balance for H's by adding H+. Now we have 12 plus 12 is 24 H pluses on this side, and we have 0 on this side, so we need to add 24 H plus. Okay, and then we need to balance for electrons. It's very easy here because it's 0 here and 24 here, so we have to add 24 electrons. So this is oxidation. Now we'll do reduction. And we need to make sure we have our other species produces C2H5OH, and we add a 3 here to balance for the carbons. Then we have to balance for oxygen, so 6, and we only have 3 there, so we've got to add 3 waters. Then we balance for H by adding H+, so we've got 6 here. Oh, whoops. We have 12 H's here, and then we have 18. 18 and 6, 24. So we've got to add 12 H pluses, and then 12 electrons. Okay, now what we need to do is times it so that the electrons are equal. So we'll have to times this whole thing by 2. And we'll just add them together. So if we times it by 2, this will be 2, this will be 24, this will be 24, this will be 6, this will be 6. So we add them together, C6H12O6 plus 2C6H12O6 plus 24H pluses plus, I'm going to just remove the electrons now, plus 6H2O produces 6C2H5OH plus 6CO2 plus 24H pluses and 6 waters. Now we cancel out, the waters cancel out, the H's cancel out. This turns into 3C6H12O6, and simplified, this would be a 1 and these 2 would be 2's. So C6H12O6 produces 2C2H5OH plus 2CO2. And we're going to have our states. Aqueous gas. Okay, and for the final one, I'm going to give you guys a little bit of a tricky one. And that is when we oxidize ethanol. Actually, we'll even go propanol to propanoic acid. And we'll add to it Cr2O72 minus plus H plus. Okay, so Cr2O72 minus goes into Cr3 plus, just so we know. So Cr2 2072 minus has an oxidation number of 14 equals minus 2 positive 12, so plus 6 to plus 3. So we're looking for a gain of 3 electrons per chromium. So this will be a reduction. This is one that you have to be very familiar with. So balance for elements other than H and O, then we add 7 waters and we add 14 H pluses, and then we add electrons, so we have minus 2, that's plus 12, and plus 6, so we've got to add 6 electrons, 3 electrons for each chromium. Okay, then we'll do propanol, CH3, and this will be oxidation. CH3, CH2, CH2OH goes into CH3, CH2, COOH, and this is aqueous and that's aqueous. So valence for elements other than H and O, they both have 3 carbons, so that's all good. Then we go the number of waters, oxygen, sorry, so we need to add 1 water to this side because we have only 1 oxygen, we've got 2 on that side. Then H's, well, we've got 3, 4, 5, 6, 7, 8, 9, 10 on this side, and we've got 3, 4, 5, 6 on this side, so we've got to actually add 4 H pluses to this side. And then we add 4 electrons. Now let's just make sure that that does make sense. If you do break up your propanol, oops, we'll do it up here. This will be plus 1, plus 1, plus 1, minus 2, plus 1, plus 1, plus 1, plus 1, plus 1. Now the carbons will have to be, you do them individually, so this carbon will have to be minus 3, this one will have to be minus 2, and then this one will be plus 3, minus 2 is plus 1, minus 1. And then it goes into, this would have to be the same, whoops, minus 3, minus 2, minus 2, minus 2 plus 1 is minus 3, so positive 3. So it has in fact lost 4 electrons, which says it there. Then to balance for the overall equation, it's quite tricky. We've just got to make sure that they equal the same thing. So you could make it equal 12, for example, by timesing this side by 3 and by timesing this by 2. So let's just write those in. So 28, 12, 4, 14, 3, 3, 3, 12, 12. Cross the electrons out. Cross the waters out. 11 waters on that side. H plus, there's 28 there, and only 12 there, so 16 on that side. So the overall equation would be like this. Okay, there you have it. You can always double check to make sure, oh, I'm missing a CH2 there. You can always double check to make sure that your charges balance in the full equation. So on this side there is -4 plus 16 is plus 12. And on the other side we've got 4 times positive 3 is plus 12. You can make sure also that the elements are equal, like there's 4 chromiums on this side and 4 on that side, and the H's and the O's. But that should be right. Okay. Well, good luck balancing the rest on the worksheet, and see you later.